So now we're going to look at the trigonometry on a right triangle. So we typically will look at trigonometry either on triangles or on circles, and we're actually going to show that they're equivalent. And the measurements that we looked at in the last video, basically the degrees are usually used with things like triangles, and the radians are used with circles more often. Okay, so it's not common that you would see the trigonometry on a right triangle be measured in radians. Okay, so if we have a triangle, right triangle, meaning that there's a triangle with a right angle, and we have some angle, usually we use the Greek letter theta for angles. Okay, theta. You can use whatever you want though. You can just use x or whatever. Usually angles in general are usually written as either a capital letter or a Greek letter. Okay. So let's just say that we have some sides A, B, and C here. Okay. Then we define some what we call the trig functions. Okay. Trig functions, trigonometry functions. Okay. Specifically, well, there's really 6 functions that we can make, but they're all based on 2 big ones. The first one is what we call sine. Okay, sine. So this is written as sine of theta. So sin and then theta, and you could put parentheses around the argument if you want to, or you could just leave it like this if it's clear. And on a triangle, this is going to be equal to the opposite side of the angle, which in this case is B, divided by the hypotenuse of that triangle, which in this case is C, the hypotenuse being the largest side. Okay. So sine of theta equals B over C in this case. Or if you want to just write opposite over hypotenuse, if you want to be a little more general. Okay. And then the second big one is cosine. Okay. And this is written as cos theta, cosine of theta, and this is the adjacent side, which is A, over the hypotenuse. Okay. Adjacent over hypotenuse. So if we want to look at an actual triangle here. Okay, so not drawn to scale. Let's say this is 3, this is 4, this is 5, and this is our angle theta. Whoops, that didn't show up. Okay. Then in this case, the sine of theta would be equal to 3/5. And the sine of, the cosine of theta would be equal to 4/5. And then in this case, we could actually find out what the angle is by taking the inverse sine of both sides, or the inverse cosine of both sides. We're not really going to get into the inverse trig functions, but you know, they work just like all the other inverse functions would. Okay. A better application of where we could use this, say that we have a, well, we can just modify this triangle, I guess. Let's say that we didn't actually know what this side was. Okay. You know, where maybe this is Y. Okay. But we do know that this side is, I don't know, let's say 30 degrees. This is a right angle. Then we could say, okay, then sine of 30 degrees equals x over 5, right? And then x then is equal to sine of, or 5 times sine of 30 degrees. Okay. And sine of 30 degrees is something we could put in the calculator and we could get an actual number for. Okay. So if you do this, if you put this in the calculator, one thing you should note is whether your calculator is in degrees or radians. Most of them by default will be in degrees, but still just something to keep in mind here. So sine of 30 degrees is 1/2. So this is going to be 5 halves, or 2.5. Okay. So x is 2.5. This is what this is telling us. And then we could do the same thing with y. We could use cosine. We could also use Pythagorean's theorem, right? The whole a squared plus b squared equals c squared. That's fine too. Because once you have two sides of a right triangle, you can get the third side with Pythagorean's theorem. But let's do it with cosine. Okay, so cosine of 30 degrees times 5 is going to be y, right? Just using that same equation. We're doing adjacent over hypotenuse this time. So cosine of 30 degrees is 0.866. Okay, and we're going to times it by 5. So y is going to be approximately 4.33. Okay. This is actually one of the special values. So this is actually root 3 over 2. So this whole thing is 5 root 3 over 2. And you can go ahead and check that if you want. Just put square root of, I'm doing it in my calculator as I say it. I'm trying to find the square root button. There it is. Square root of 3 divided by 2, and you get 0.866, and then multiply that by 5. Okay, so this is how you would use the trig functions to actually solve for the sides of a triangle. So now back to defining them. We only defined 2. There's actually 6. Okay, so let's go ahead and look at how do we define the other trig functions. So the other trig functions. So everything is in terms of sine and cosine though. So the third most common one is tangent of theta, okay, which we write as tan. Let me write tangent right here. Tangent of theta is the ratio of sine of theta to cosine of theta. Okay. So sine of theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So this is going to simplify to opposite over adjacent. Okay. So it's written in terms of sine and cosine, which all the other ones are going to be. Okay. So then we have cosecant, which is written as CSC of theta. This is 1 over sine of theta. Okay. So in other words, hypotenuse over the opposite side. Then we have secant, SEC of theta. This is 1 over cosine of theta. Okay. Hypotenuse over adjacent. So some of the more fancy calculators will have all of these functions. Some of the more basic ones will just have sine and cosine and tangent. And then finally we have cotangent, which is naturally 1 over tangent, and we write it as COT of theta. So 1 over tangent of theta, which would be adjacent over opposite. Okay, so there's 6 functions altogether, but we really focused on sine and cosine because all the other ones can be written in terms of sine and cosine.